Hello, we're going to be talking about polynomial intercepts and multiplicity. So let's jump right into it. X-intercepts, remember, is where the graph crosses or touches the x-axis. Now, when we say crosses or touches, all the graph has to do is at least at some point hit the x-axis. Whether it goes through it or whether it bounces off of it, it doesn't matter. If your graph touches the x-axis in any way, shape, or form, it is an x-intercept. Now, where that graph touches is a coordinate point. And that is how x-intercepts must be written. Now remember, every coordinate point is x comma y. Now, for x-intercepts, the y value is guaranteed to be 0. Because no matter where we're looking, right, if we have any graph here, no matter what point we're looking at, that y value, every time it crosses the x-axis, has to be a y value of 0. Okay, now other names for x-intercepts, you might have heard these before, you might have not. The most popular ones, or the ones we're going to talk about today, is that they're known as zeros. X-intercepts are zeros. They're also known as solutions, because remember, coordinate points are solutions by definition. And the kind of less popular one is that they're also known as roots. Now, if you remember that x-intercepts are zeros and solutions, I'm happy with that. We won't really deal with the root vocabulary for a very long time, so don't worry about that. That'll be a few lessons into the future. Okay, but zeros and solutions for now. Now, zeros, again, is just a synonym for an x-intercept. The only difference is that we write those as a list of numbers instead of coordinate points. So x-intercept are written as the coordinate point, right? Versus a zero is a list. So if I have, let's give an example. Let's say that I have x values of 1, 2, and 3, or so on. Right? If I'm writing them as zeros, you would literally just write them like that as a list, 1, 2, 3, and so on and so forth. If I was writing them as x-intercepts, that would be 1, 0, because y is guaranteed to be 0 for an x-intercept, and then I would continue writing them as coordinate points, right, for as many x values as I had. And that's going to be the difference. They're the same thing. You both have x values of 1, 2, and 3. It's just changing how you write them. Okay, so we're going to talk a lot about zeros and x-intercepts today. So example 1, it says find the zeros and x-intercepts. AKA, it's asking you to find the exact same thing, just write the same thing 2 different ways. That is what this is asking. Now, we have 4 examples here. I'll do the first 2 a little quickly, right? And then we'll do one at the last as well. When we're looking at this, we have 4 different polynomials. Now, how we're going to tackle these, right? For this polynomial, we have y equals all of this stuff. Now, hopefully, this looks a little more familiar to you. We've been factoring polynomials for the past 2 lessons, and that is what this polynomial has, or what this polynomial, what its form is. It's in factored form. And we can tell because everything is being multiplied. Everything's side by side, right? It's all being multiplied one to the other, which tells me it's in factored form. Now, why this is significant is if our goal is to find an x-intercept, remember that's always going to be that x comma 0 in form, right? That means that y is guaranteed to be 0. That means that this whole equation equals 0. And this is why it's important that we know it's in factored form and why we have 0 as the y value, is because we can do something that's called the zero product property. Now, if you know what the zero product property is, great. If you don't remember it from this point onwards, it'll break my heart, but also great. Okay, all the property says is that if you have a bunch of things all multiplied together that equal 0, you are guaranteed that at least something on the right, one or more things, has to be 0 as well. And this is what allows us to solve equations. What that's really saying is that out of the 4 things we have multiplied here, we're going to get some things that equal 0. So everything that's getting multiplied, we have the 2 in front, we have the 2x in parentheses, we have the x minus 5, and we have that negative 2x minus 2. And that property tells us that I can set all 4 of those things equal to 0, because we're saying all of them are being multiplied and they equal 0. So let's logically run through these. The first one, 2 equals 0, is nonsensical. It doesn't make any sense, because can the value of 2 equal 0? If I have 2 pizzas, is that the same thing as having no pizza at all? No, it is not, right? That is not true. There is no x for you to solve for. There's nothing for you to do. You can't divide by 2 because what would that even do? You get 1 equals 0 then, and that's still not helpful, right? So this first 2, we're going to ignore it, and we totally can because there is not an x attached to it. The rest of these, can we solve for x? Absolutely. So when you hit a case like this, and it's going to be the same for example B as well, right? If there's ever a number out front, like if we had a 4 there, we're not going to worry about it unless that was a 4x, right? So if there's ever an x involved, set it to 0. Okay, so let's finish solving these. We have 2x equals 0. So divide by 2 both sides, we get 0 divided by 2. So in other words, 0. All right, the next one, we have x minus 5, undo subtraction with addition. So we're going to add 5 to both sides. So x equals positive 5 when we add the 5 over. Now this next one we'll just do in 2 steps. So we have negative 2x minus 2 equals 0. Undo subtraction of 2 with addition. So add the 2 over. And then my next step would be divide by negative 2. So x equals 2 divided by negative 2. So in other words, negative 1. And some of you might be wondering, oh, Miss Diddy, there was something weird next to that 2x. That was 2x to the third. Well, technically, what we have written there is, I'll just type it off to the side. So we had 0 equals 2x times 2x times 2x, right? Because 2x to the third, right, that 3 on the exponent means that we have 3 of those parentheses, right? That is what this expression is really saying right there. Now, if I break down each one of these individually and I set each one of those individually to 0, we still get the exact same expression, 2x equals 0, in all 3 of them. Or in other words, you'll get the same value of that 0, literally 0, is coming back. So when you're finding zeros and x-intercepts, the exponent does not matter. Does it have significance? Yes, that's the next page. Okay, and as for this problem, we're done. We wanted to find what are the zeros. Well, we found them. That was literally the value of 0, 5, and negative 1. Remember the x-intercept, they're the exact same thing. They're the same values, right? We have an x value of 0. Well, I know the y value is also 0. We have an x value of 5. I know the y value is 0. And I have an x value of negative 1. I know the y is 0. All you're doing is stating the exact same information 2 separate ways. Does it matter the order that you write them in? No. No, it does not. There you go. Problem. Done. Solved. That's all it's asking you to do. Very helpful when it's in factored form and everything's multiplied. So this next one, we can do a little bit faster, same idea. Everything with an x, we're setting to 0. So in my parentheses, I have an x, set it to 0. Next parentheses, I have an x plus 6. Set that to 0. Next parentheses, we have an x minus 2, set that to 0. Right? And for all 3 of those, we just solve. The first one's 0. That's done. All right. Next one, subtract the 6. So subtract 6 both sides, minus 6, negative 6. The next one, we add the 2 to both sides. So x equals 2. And there you go. And again, that's only possible because we set our y, right, f of x, ooh, that's a wonky y, because we set our f of x, which is our y value, right, and our y is getting set to 0. Right? That is how or why we can set each one of those pieces to 0. So zeros for the next function will be 0, -6, whoops, and 2. If you wanted to write them as x-intercepts, just write them as a coordinate point. That first x value, comma 0. Second x value, comma 0. Third x value, comma 0. And that's all it's asking for when it says what are the zeros and x-intercepts. Okay, now the next problems are, what if it's not in factored form? That's not a problem. Factor it, right? We know y is 0 when we're finding zeros and x-intercepts, so we can just move on, right? 0 equals. Okay, so 0 equals, and then we just need to factor it. Now remember, your first step to factoring is looking for a GCF. You have the numbers 2, 6, and 20. That means 2 is in common. They all have an x's, which means an x is also in common. Your GCF is 2x. Let's pull it out, right? If I pull 2x out of 2x cubed, well, 2 divided by 2 is 1. 3 x's, take 1 out. There should be 2 left over. This is not going to write well, so I'm just going to put a little 2 there. Right, and then from there we have 6 divided by 2, so plus 3. 2 x's, take 1 out, should be 1 left. -20 divided by 2, -10. We have an x, but we pulled it. That should be what's left after our GCF. Okay, now it is closer to being factored, right? We have 2 things being multiplied, but I still have this x squared stuff going on. That means that I can still factor this, right? And remember, 3 terms means that's one of your trinomials, whether you factor it with a big X or a table, up to you, right? Middle number 3, that means we are adding to 3. First times last, 1 times -10, -10. Okay, so then finish the puzzle. 2 numbers multiplied -10, but add together to give you 3. That should be 5 and -2. Right? And because your a value is +1, right? Remember our shortcut when we divide by that a value? Dividing by 1 won't change it, which means that the numbers that we see are our numbers in the parentheses. So we have 0, oops, backwards, there we go. 0 equals 2x, our GCF, and x plus 5, because 5 divided by 1 is just 5, right? And then x minus 2. If you want to factor that old school where you want to break the 3x apart with the 2 numbers, go for it. You'll get the same parentheses. And now this is in factored form, right? All of your x's are broken down. Nothing has a power larger than 1, right? And I'm not talking about the parentheses having a power larger than 1. I'm talking about the power specifically on the x. If there's ever a power on that x, you can break it down. Okay, so we have 3 things with x's. First thing, set it to 0. Second thing, set it to 0. Third thing, set it to 0, right? Everything with an x, you want to set that whole factor, that whole parenthesis equals 0. So the first thing, if I divide by 2, we get 0 back. The next one, if I subtract 5 both sides, right? And the next one, if I add 2 both sides. Right, so if I had to write, what are my zeros? We'll get 0, -5, and 2. If I want to look at what are the x-intercepts, that'll be first x value, comma 0, next x value, comma 0, next x value, comma 0. Okay, there you go. If you want to do that last example, go for it. Check out the notes filled in if you want to make sure you're correct. But those are zeros and x-intercepts. So if I want to look at now, turn the page, multiplicity of zeros. What is it? What does it do? Well, multiplicity the word multiple, right, is kind of within that word multiplicity. And that's really what this means. When we say multiplicity of zeros, we're saying how many multiples, how many of that zero do you have? So when a zero is repeated, the same factor occurs multiple times, right? And what this means is, let's kind of finish writing off onto this thing, right? It says equals, and we can kind of finish writing this because I have the 1/2 there, right? But we also have that square. Remember, that means I have 2 of that thing sitting there. So I could rewrite this as x minus 1 and an x minus 1 with the x plus 2. Right? That exponent just means I have 2 of the same thing. That means that its multiplicity, I have 2 of the same thing. I have multiples of it, right? So when we're talking about multiplicity of something, essentially look at the exponents, or exponent, I guess, on a factor. So that means for my first factor, for this x minus 1 factor, its multiplicity is 2, because I have 2 of them, right? So let's just write this off to the side. For the x minus 1 factor, right, if I were to actually set that equal to 0, right, add the 1 both sides, we get 1 as the 0, right? X equals 1. The intercept, 1 comma 0. And because there's 2 of that x minus 1 in my equation, its multiplicity is 2. There are 2 at the parentheses, right? Versus if I were to look at the x plus 2 parenthesis, right, if we have that x plus 2, and I set that equal to 0, right, then we get x equals negative 2 is the 0 value. So negative 2 comma 0 is the intercept. There's only 1 of these in my equation. There's not more than 1, there's just 1. So it has a multiplicity of 1. Now, as for cross or bounce, this is looking at the graph. And fun fact, this graph is the graph of my f of x here. If I were to actually graph that thing out, this blue line, this blue curve, is what we have. So when we say cross or bounce, look at the point, right? We have 1 comma 0 right there. Now at that point, what is my graph doing? Is it crossing the x-axis or is it bouncing off of it? Well, my x-axis is that horizontal line right there, right? It's not going through it. We can see that, the dot is touching it. We can see that right there, but it's not going through, which means that that is bouncing off of it. The other one, at negative 2 comma 0, that point is cross. It's crossing it. That's all it's asking. Okay. Now, we have another example. I'll go through this one a little faster. First factor, we have x minus 3. Right? We set that to 0, we get x equals 3. So 3 comma 0 is the intercept. Now I look at my equation and I say, how many of those do I have? There's only 1 of them, right? It has an exponent of 1, so it has a multiplicity of 1. 3 comma 0, it is crossing. For the x plus 2 factor, if I set that to 0, we get x equals negative 2. The intercept is a negative 2 comma 0. And how many of those do I have? Well, I can see specifically on that factor there are 2 of them there, so there's a multiplicity of 2. If I look on the graph, negative 2 comma 0, the graph is not crossing the axis, it is bouncing off of it. Now you might be wondering, wow, why do I care what the multiplicity is? Maybe, hopefully, you've seen a pattern so far. If we have a multiplicity of 2, the graph bounces. Versus if we add a multiplicity of 1, the graph crosses the x-axis. Now, I could show you more graphs, but I'll summarize it as so. If you have an even multiplicity, so if the exponent is 2, 4, 6, 8, etc., the graph will always bounce. Let me just... Okay. If you have an odd multiplicity, so 1, 3, 5, 7, etc., right, then the graph will cross. This is like the most important thing, one of the most important things you get from this entire page. If the multiplicity is even, bounce odd cross. Okay? So, another example, finding all the same information. We can go through this one very quick. For this first factor, you're going to have a 0 of 1. Right, which means that the x-intercept will be 1, 0. And we see one of those parentheses, so it'll cross. I don't need to look at the graph. I know there's one of those. There we go. This next one's a little more interesting, right? That's 2x minus 1 equals 0, which means if you add the 1, we get 2x equals 1. So in other words, after we divide by 2, x is 1/2. So the next one will happen at 1/2. So that x-intercept is 1/2, 0. Fractions are totally fine. Deal with it, right? How many of those parentheses do we have? Well, exponent is 3. You have 3 of them. Odd number, which means it crosses the x-axis. Same thing here. Negative 3x plus 2 equals 0. Minus the 2 both sides, negative 3x equals negative 2. Divide negative 3, x equals 2/3. Still totally fine that it's a fraction, right? So we have the 0 at 2/3, which means the intercept is at 2/3, 0. So its multiplicity, look at its exponent, we have 2 of them, which means that because 2 is an even number, it will bounce off of the axis when we do graph it. The last one, if we set that to 0, we get x minus 2 equals 0, so 2 is the 0, which means 2, 0 is the intercept. We don't see any exponent written, which means that's an exponent of 1, which is an odd number. It crosses the axis. And this is what we need. This is our first step to actually graphing polynomials, which is what we'll do in 2.8, right? It'll be a long ways away, but this is kind of how we start piecing those graphs together. All right, last piece, almost there. So we have example 3, identify the x-intercepts, rewrite them into factors. All right, so we have the graph, and then we know x-intercepts is where the graph will cross or bounce off of the axis. And it just wants us to find the factors of them, right? So I know that's negative 1, 0. So in other words, an x value of negative 1. Now, in order to go from, right, those factors, right, here's the factor, right, we set those factors to 0 and solve to get the zeros, aka the intercepts. It's literally just going back that direction. We know what the intercept is, which means we know what the 0 is, which means we can just work it backwards to find the factor, right? In other words, when we have it equal 0, you know you're looking at the factor. So I'm going to add the 1 back over. So then we get the factor of x plus 1 equals 0. And as soon as it equals 0, that tells you that in the equation, I don't know what the full equation is, but I know that my f of x, my y, actually, hold on. I don't know why I'm trying to write that out. We'll do it this way. Equals, I know one of the parentheses will be x plus 1. Could there be more? Absolutely. There could be a number out front, there could not. I have no idea, but I do know for sure that x plus 1 is a part of it. Next thing that we have is that we have an x value equals 1/2. Right? Now this is kind of a weird case, right? When we're looking at the factors, right, we had 2 examples of fractions zeros, right? Were those factors written as x minus 1/2 and x minus 2/3? No. They were actually written a little differently where we had no fractions in there. That's our goal. So whenever we see kind of this fractional idea, right, let me rewrite this one a little bit with the pencil so it'll be a little easier to see. X equals 1/2. Right? Our goal is to get rid of the fraction. Fractions are division. You undo division with multiplication. I'm going to multiply 1. So I multiplied 2 both sides. So we got 2x equals 1. Because, right, the times by 2, divide by 2, cross each other out. Now the reason why I did that is that now, no more fraction. And if I wanted to move this, I would just subtract 1 both sides. Right, minus 1 minus 1. So then we end up back at 2x minus 1 equals 0. And that's the true factor. So you're never actually going to write x equals 1/2 or x minus 1/2 inside those parentheses, right? Like, you'll never see that written there. You have to clear the fraction. It's probably the most confusing thing as far as going back from graph back to the factors. But if you were to write the equation, 2x minus 1 would be there. All right, now let's, just for kicks and giggles, all right, let's kind of mention this over here. I won't do both these examples, but I will mention it. That's at -1/4. Sometimes when students look at this, they're like, oh no, where does the negative go? Just keep it with the numerator, right? If I were to undo that, I would just times by 4, not -4. Undo that 4, we get 4x equals -1. And then I would add the 1 over, so 4x plus 1 would then be the factor. Okay, and then the last but not least, we have an x value of 3 chilling there. So if we have x equals 3, I would just subtract the 3 both sides, so x minus 3. And then as soon as it gets that equals 0, that means I'm staring at my factor, so x minus 3. I don't know what the multiplicity, I mean, I could guess what the multiplicities are, right? This has a multiplicity of at least an even number. This has a multiplicity of an odd number, right? I don't know what the exponents are. I can guess at them, but I don't know yet, right? But as far as the factors go, I do know that one of the factors has to be x plus 1, 2x minus 1, and x minus 3. On your assignment, that's all it's going to ask for, is what would be the parentheses in there. Okay, y-intercepts, we've already talked about these. I'll go through this last section just to remind you. Okay, if an x-intercept is where the graph crosses the x-axis, then where the graph will cross the y-axis is your y-intercept. Now, notice I said cross and not cross/touch. Like, it will never actually bounce off of the y-axis. It will always cross. Okay? Now, those are also written as a coordinate point, right? With x always guaranteed to be 0. All right? Now, for this one, let's do an example, and then I'll fill in that last blank. We've done these on Unit 1, so just remember to find a y-intercept, right? We just said that x is guaranteed to be 0. Literally, put 0 into every x that we see, and you find the y-intercept. It's going to be a little hard because there's kind of a lot there. So our function, when x is 0, in other words, you know, when our y value is going to be equal to a negative times 0 minus 1. And then we'll have 2 times 0 minus 1 raised to the third power. And I'll just draw that 3 in because I can't do exponents well. And that is then multiplied to -3, which now has times 0 instead of x. And that is to the second power. And then we have 0 minus 2. So notice on all of these, nothing else has changed. The exponents are the same. The negative is still in front, right? All of the parentheses are still there. The only thing we changed is that instead of x, 0 is now in its place. And then we just evaluate, right? So the next one, our y value is equal to that negative in front. 0 minus 1, -1. 2 times 0 is 0 minus 1, -1. And that's still to the third power. All right, negative 3 times 0 is 0, plus 2, 2. And that's still squared. We haven't done anything yet. This is PEMDAS, right? Stuff in parentheses first before exponents, multiplication, or anything else. And then 0 minus 2, negative 2. All right. PEMDAS then says that you need to do any exponents before multiplication, order of operations. So I'd say, okay, negative 1 to the third, well, that's negative 1 times negative 1 times negative 1. That's just negative 1. So we get y equals that negative times negative 1 times the negative 1 to the third, which is just negative 1. Now our next thing is that we have 2 squared, and 2 squared is 4 times negative 2. Notice all those parentheses are still there. You're still multiplying all of this together. It was multiplication to begin with. It's still multiplication now. So then we have a negative times a negative times a negative. So a negative, right? And they're all ones, which means that's just going to be negative 1. So negative 1 times 4 times negative 2. So that would be negative 4 times negative 2, which is positive 8. So we plugged in 0 for x, we got back 8. That is your y-intercept. We've talked about y-intercepts a bundle, right? The biggest thing is take your time with it, right? Make sure that you evaluate your exponents before you multiply your parentheses together. If there was a negative in front, make sure you bring that negative down all the way, right? And if you're confused, if you're like, oh man, I don't know what to do, you could plug this whole thing into your calculator and it will do order of operations correctly for you, right? As long as you recognize that 0 has to go in for every x, and you can keep going from there. Okay? Now, these are my absolute favorites. Let's do example D and we'll end off with there, right? F of x, remember, that's just a fancy way to write y. So y equals, and then if I wanted to find the y-intercept, well, that would just be 0 for all of the x's, so 0 to the third power, plus 5 times 0 squared minus 0 minus 5. So 0 cubed, yeah, it's 0. 0 squared, 0. Times 5, still 0. Minus 0, yeah, it's still 0. So then 0 minus 5 is negative 5. Okay? In other words, if you're in standard form, right, that was so much easier than all of the work we had to do if it's in factored form, right? If you're in standard form, your constant, aka the thing without an x, is going to be your y-intercept. So in our case, plugged in 0 for x, got back negative 5, there's your y-intercept. Right? What happens if nothing, or sorry, what happens if everything has an x? Well, the constant value is 0, which means so is your y-intercept, right? So the last blank to this one is, it's related to the constant of the polynomial if it's in standard form, right? Remember, the constant, if it's in standard form, will be the last term without the variable. Okay, if all of them have an x, then when you plug in 0, right, it'll wipe out every one of those terms, right? And it literally just gives you 0 back entirely. So then we'll have the y equals 0 if we plug that in. So 0 comma 0 would then be the y-intercept. Okay, so reminder, that was kind of a long video. It's longer than I wanted it to be, but that's kind of the comprehensive lesson, everything that you could possibly know when it comes to zeros and multiplicity. Thanks for watching.